everyone, and welcome back. Have you ever looked up at the night sky and wondered what's really out there? Beyond the stars and planets we know, there's a whole universe of objects zipping around, and some of them get pretty close to home. Today, we're diving into a topic that sounds like it's straight out of a sci-fi blockbuster, Near-Earth Objects, or NEOs. But don't worry, this isn't about fear-mongering. It's about understanding our cosmic neighborhood a little better. So, what exactly is a near-Earth object? Think of them as space rocks, asteroids, and comets that have been nudged by the gravitational pull of nearby planets into orbits that bring them within our general vicinity. To be specific, scientists classify an object as an NEO if its path brings it within about 1.3 astronomical units of the Sun. An astronomical unit, or O, is the distance from the Earth to the Sun, which is roughly 93 million miles. So, anything that comes within 1.3 times that distance is on our radar. That might still sound like a huge distance, and it is. But in the vastness of space, it's considered just around the corner. Now, you might be thinking, okay, so there are rocks in space. What's the big deal? Well, these aren't just tiny pebbles. NEOs can range in size from a few feet across to several miles wide. The smaller ones are actually hitting our atmosphere all the time. You might have seen them as shooting stars or meteors. They're beautiful, and they burn up harmlessly before they ever reach the ground. But what about the bigger ones? That's where things get interesting. Let's break down the two main types of NEOs, asteroids and comets. Near-Earth asteroids, or NEAs, are rocky, metallic bodies that mostly originate from the main asteroid belt between Mars and Jupiter. Imagine a cosmic traffic jam where, every now and then, a gravitational nudge from a giant planet like Jupiter sends one of these asteroids careening into the inner solar system. We've discovered over 30,000 of these so far, and that number is growing every day. Then you have Near-Earth Comets, or NECs. These are often called dirty snowballs. They're made of ice, rock, and dust. Unlike asteroids, which come from the relatively nearby asteroid belt, comets come from the far, frigid edges of our solar system, like the Kuiper Belt or the Oort cloud. As they get closer to the Sun, the ice starts to vaporize, creating that beautiful, glowing coma and a long tail that can stretch for millions of miles. While they're spectacular to look at, their highly unpredictable orbits make them a bit trickier to track than asteroids. So, we have these rocks and ice balls zipping around. Why do we spend so much time and money looking for them? This brings us to a subcategory of NEOs called potentially hazardous objects, or PHOs. This sounds a lot more dramatic, right? A PHO is an object that's larger than about 460 feet in diameter and whose orbit could bring it within 4.6 million miles of Earth's orbit. To put that in perspective, 4.6 million miles is about 19.5 times the distance to the Moon. Still a long way off, but close enough for astronomers to say, hey, we should probably keep an eye on this one. The reason for the size threshold 460 feet is because an object of that size or larger could cause significant regional damage if it were to impact Earth. It wouldn't be a global, extinction-level event, but it could certainly devastate a city or an entire region. Anything smaller would likely burn up in the atmosphere or, at worst, cause a localized airburst, like what happened over Chelyabinsk, Russia, in 2013. That meteor was only about 65 feet wide, but the shockwave it created shattered windows and injured over 1,000 people. It was a wake-up call, demonstrating that even relatively small objects can pack a serious punch. Now, before you start building a bunker in your backyard, let's talk about the chances of an actual impact. The good news is, a major impact from a large asteroid is an extremely rare event. Scientists have already identified and tracked more than 95% of the truly massive, civilization-ending asteroids, those over a kilometer wide, and none of them pose a threat for the foreseeable future. The famous one that wiped out the dinosaurs 66 million years ago was about 6 miles wide. We can rest easy knowing that another one of those isn't lurking around the corner without our knowledge. The real challenge lies in finding all the smaller, yet still dangerous PHOs in that 460-foot to 1-kilometer range. There are estimated to be thousands of them out there that we haven't found yet. It's like looking for a piece of charcoal in the dark from millions of miles away. It's incredibly difficult. But humanity isn't just sitting back and waiting. We have a global network of telescopes, both on the ground and in space, dedicated to scanning the skies. Programs like NASA's Planetary Defense Coordination Office coordinate these efforts, acting as Earth's cosmic watchdogs. Projects like the Catalina Sky Survey, Pan-STARRS, and the upcoming Vera C. Rubin Observatory are designed to detect these objects, calculate their orbits, and predict any potential close approaches decades or even centuries in advance. Finding them is the first step. The second, and arguably cooler, step is figuring out what to do if we ever find one on a collision course. And no, the answer isn't to send Bruce Willis with a nuclear bomb, like in the movie Armageddon. Scientists have much more practical and realistic ideas. The key is to find the threat early years or decades ahead of time. If you have enough warning, you don't need a massive explosion to save the day. All you need is a tiny nudge. Think about it like this. If you slightly change the course of a speeding car that's a mile away from a target, it will miss by a wide margin. It's the same principle in space. A small, precise push on an asteroid years before a potential impact can alter its trajectory enough so that it sails safely past Earth. This isn't just theory anymore. In 2022, NASA successfully conducted the Double Asteroid Redirection Test, or DART mission. They intentionally crashed a spacecraft about the size of a vending machine into a small asteroid moonlet named Dimorphos, which was millions of miles away and posed no threat to us. The goal was to see if the impact could change the asteroid's orbit. And guess what? It worked, even better than expected. The DART spacecraft slammed into Dimorphos and shortened its orbital period around its larger parent asteroid by a full 32 minutes. This was a monumental proof of concept, showing that we have the technology to defend our planet if we ever need to. This kinetic impactor technique is now a proven tool in our planetary defense toolkit. Other ideas are also on the table. One is a gravity tractor. This involves parking a heavy spacecraft near a threatening asteroid and just letting its tiny gravitational pull slowly tug the asteroid into a different path over a long period. It's a gentle, precise method that avoids the risk of shattering the asteroid into smaller, harder-to-track pieces. There are also more advanced concepts, like using focused laser beams to vaporize parts of the asteroid's surface, creating tiny jets of gas that act like thrusters to push it off course. So, while the idea of a giant rock hurtling towards Earth can seem terrifying, the reality is that we are living in the first moment in history where we can actually do something about it. For billions of years, life on Earth was at the mercy of the cosmos. The dinosaurs never saw it coming. We can. The study of NEOs isn't just about doom and gloom either. These objects are pristine relics from the formation of our solar system about 4.6 billion years ago. By studying them up close, we can learn about the building blocks of planets, including our own. Some scientists even believe that asteroids and comets delivered water and the organic molecules necessary for life to a young Earth. Missions like OSIRIS-REx, which successfully collected a sample from the asteroid Bennu and brought it back to Earth, are giving us unprecedented insights into our own origins. These space rocks are like cosmic time capsules. Furthermore, looking ahead, asteroids could become vital resources for future space exploration. They are rich in water, which can be broken down into hydrogen and oxygen for rocket fuel and breathable air, as well as precious metals like platinum and gold. The idea of asteroid mining might sound futuristic, but it could one day be the key to establishing a permanent human presence in space, allowing us to refuel and build structures without having to launch everything from Earth's deep gravity well. In summary, near-Earth objects are a fascinating and vital area of study. They are the leftovers of creation, potential threats, scientific treasures, and future resources all rolled into one. They remind us that we live in a dynamic, ever-changing solar system, but they also showcase human ingenuity and our incredible ability to understand the universe and protect our place within it. The work of scientists and engineers in planetary defense is a quiet, ongoing effort that ensures our planet remains a safe haven for life. It's one of the greatest collaborative scientific endeavors of our time. So, the next time you look up at a shooting star, remember the bigger picture. It's a tiny glimpse into the vast cosmic shooting gallery we call home. But thanks to dedicated people all over the world, we're watching the skies and we're prepared. Thank you so much for hanging out and exploring this cosmic topic with me today. If you enjoyed this video and learned something new, please hit that like button and don't forget to subscribe and turn on notifications so you don't miss our next adventure. Let me know in the comments what you think about NEOs or if there's another space topic you'd like me to cover. Stay curious, and I'll see you in the next video.